Today we'll be talking about what you need to know about proofs for proving congruency. Congruency means that we have two things that are the same size and the same shape. If we're talking about triangles, there's a couple different ways to prove congruency from before, and we've got side angle, side angle, side angle, lots of different things. We'll go over that later. But basically, once we prove that these two triangles are congruent, then we can say if A, B, C is congruent to D, E, F, we write it out like this. Triangle ABC is congruent to triangle DEF. Once we can prove that congruency, then we know that corresponding pieces of that triangle are going to be congruent. So C corresponds over here with F, and B corresponds with E, and A to D, and so forth. So basically we know that A is congruent to D, and C is congruent to F, and B is congruent to E. Similarly, we can say line AB, or side AB, is congruent to side DE. But we're getting ahead of ourselves a little bit. Basically, once we prove that those two triangles are congruent, then we know that corresponding parts of those triangles are congruent. The reason being is called CPCTC. Corresponding parts of congruent triangles are congruent. Corresponding parts, in parentheses, of congruent triangles in parentheses again are congruent. Most of the problems we're looking at are saying, how do you prove that AB is congruent to DE? And you have to show all the steps it takes to prove that these two triangles are congruent before you can say that AB is congruent to DE. So let's take a look at what some of those reasons might be. So the first one I wrote down for you, given, the information given in the problem. That's given. Whatever they said at the beginning, AB equals CD, or M is the midpoint of blankety blank, that is your given information, and that is information you can use in your proof. So definitely write that down. Your first two steps of your problem should be this information, reason, given. This information, reason, given. All the information they gave you. Now the definition of a midpoint tells us that if we have a midpoint, it is splitting something in half. So for definition of a midpoint, say we have a segment, either part of a triangle or something, that they gave us in the given. They said B is the midpoint of AC. Well, what does that really tell us? That tells us that AB is the same as BC, since it splits it exactly in half, like little dots here. So by the definition of the midpoint, we can say that AB is congruent to BC. Now a definition of an angle bisector, similarly they might say in the given, they might say, this is point M, N, O, and P. Their given could be that MO bisects angle NMP. So that's your given information. MO bisects angle NMP. So then from there, if it bisects it, we know that this angle is the same as that angle. So the result of that is that angle NMO, which is this little guy right here, is congruent, since it's exactly the same, as OMP. So a step you can take in your problem is, given MO bisects angle NMP, then the next step you can say is angle NMO is congruent to angle OMP because of the definition of angle bisector. Another statement that's often given is that something is perpendicular to something else. Let's say XY is perpendicular to WZ. So in our problem we've got perpendicular lines. Here's XY, here's WZ. When you see this in the given, and if the picture's in front of you, the best thing to do is just draw your little box that means that it's perpendicular. Now what does perpendicular really means? It means that that angle right there is 90 degrees. If that angle on that side is 90 degrees, and we know that all the way around it's got to be 180, we know that this side is also 90 degrees. So if you need to make the statement that this angle is congruent to this angle, angle XZW is congruent to angle YZW, the reason for that would be that all right angles are congruent. We know that angle XZW is 90 degrees, and we know that angle YZW is also 90 degrees. So the reason being would be all right angles are congruent. Another important one to talk about is this reflexive property of congruence. It's not actually, the word sounds more confusing than it actually is. Let's say that this is H up at the top and Z down at the bottom. Basically, all the reflexive property saying is if HZ looks in a mirror, its reflection, it's still going to be HZ. And you can count it for multiple things. So let's say we're looking at this triangle. And we're trying to prove that HAZ is congruent to HBZ. And say we've already found out that Z is a bisector, or I'm sorry, a midpoint. Z is a midpoint. And that these two sides, AH and BH, are also congruent. We need one more piece of information to find out if these two triangles are actually congruent. Well, funny enough, HZ is HZ. Therefore, HZ is congruent to itself. Now this seems super obvious, but you have to include this in the proof. HZ is congruent to HZ by the reflexive property of congruence. Like I said, if it looks in the mirror, it's still itself. If you folded that onto itself, it would still share one side, and that shared side is HZ via the reflexive property of congruence. So let's recap. When you have two triangles and you're trying to prove that they're congruent, we've got our ABC and DEF. If we have the information that A and D are congruent and that B and E are congruent, and we know that these two sides are also congruent, AB and DE, then by angle, side, angle, we know that those two are congruent. Your other options for these, it might not be angle, side, angle every time. It can be angle, angle, side, side, angle, side, 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 side. So these four options here are how you will prove that two triangles are congruent. Now if we go back to what we talked about at the very beginning, once we've proved congruency, then we can say that any part of those are congruent. So the last step of most of your proofs is going to be this CPCTC, and you just have to memorize it. It's corresponding parts of congruent triangles are congruent. Say it 5 times and you'll probably remember. Corresponding parts of congruent triangles are congruent. Really important. Like I said, this will probably be the last step because you've already given all the given information. You've deducted some things from that given information via figuring out what angles are the same, what sides are the same. You then prove those two triangles are congruent by side, angle, 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 side, or side, side, as we just talked about. And then from there, you can say, okay, I know that these two sides are the same because these two triangles are the same. And the reason, once you say AB is congruent to DE, you can say because of CPCTC.